हॅलो. हा बघते. हा
हॅलो.
हा
अरे खाली 4 जण झाले. चालू करू का? ठीक आहे. नाही तर मी आता चालू करतो. दोन राणींनो. हा तू काय देते. बसा. Okay. Yeah, now the screen is visible, no? Hello? 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 Okay, so we'll continue. Now, in this particular example, the machining plan is 3 holes has to be drilled. So, what will be the statements? So, P1, that is point, it is at a distance of 1 in x, then 2.7, that is in y, and 0.1, that is above this surface. Similarly, you have point 2, that is at a distance of 1 plus 1, 2, and then point number 3. So it's a very simple example to begin with. Now, few terms you should be familiar. That is, one is macro. So call statement for the macro is you have to just write call followed by macro name. Macro is nothing but it's a kind of a sub program in which we have to write repetitive instructions. And the statement for ending the macro is termac is nothing but termination of macro, and it is written as termac. Now this is the machining plan. So you have delta, that is the name of the macro. Delta is nothing but a macro which is defined by x and y coordinates. So go to dx dy means it will go to the x coordinates and y coordinates which are defined in this macro. So macro is nothing but like a subprogram. Then go delta. Whenever you write to go to, it means a rapid movement, and when you write to go delta, it means it is feed movement, feed. And go to is nothing but a rapid movement. So in this particular macro, x coordinates and y coordinates are defined. So call statement is delta is equal to macro oblique ds comma dy, and end statement for the macro is terminate. So how do you call it in a main program? That is from P0, that is nothing but from this point P0 call, that is you are calling macro which is named as delta, and you have to give these coordinates only. Dx is equal to 1 and dy is equal to 2.7. Similarly, and similarly third point. So whatever has been mentioned in this macro, that will happen at this point. And then finally go to PO, that is nothing but this start. So that was a small example stating the use of macro. Now how to do contouring? Contouring is nothing but a contour milling. So before we go for the contour milling example, you must understand some terms like part surface, drive surface, and check surface. You can see in the next slide how the part surface, drive surface, and check surface are defined. Part surface is nothing but it is the surface on which the end of the tool is riding. That is, look at this left hand side here. So now this is the part surface, this on which the tool is being machined. Then drive surface is nothing but a surface against which the edge of the tool rides. So this is what is your dry surface is. Along this surface, the tool edge is riding, and then you have a check surface. Check surface is nothing but a surface at the your tool motion will stop. So that is this. This tool is not going beyond this. That is what is your check surface. In the next slide, you will see this clearly. So this is your part surface, and this is your dry surface along which the cutter is moving. And then this is your check surface, that is up to this surface, the tool will move, or the tool will stop at this surface. I hope it is clear. I hope you have drawn this diagram. The question can be asked is in APT statements, define part surface, drive surface, and check surface, or define various kind of surfaces. This is check surface. This is drive surface. Now, in these surfaces, this is very important slide. Again, there are three types, namely to, on, and past. So to, on, and past. CS stands for the check surface. Now, to means the tool will reach till here. It will not go beyond this surface. On means tool center line will match with this check surface. And past means the tool will pass the surface. This is the difference between to, on, and past. Please draw this. So now tan 2 is nothing but tangent to. Now there are two movements shown here, that is A and B. So in A, that is this, and B, that is inside. A is outward and B is inside. So what is given in A? A is go to L1. So now where is the start point? So start point is this.
Hello, sir.
Yes,
Sir, please let Valenka in.
sorry,
Please let Valenka in.
somebody wants to join.
Yeah, sir.
Yeah, you already admitted. Is in, no?
No, sir.
No? Who is that?
Sir, it's Valenka.
Velenka.
Yeah, she's in. She's in.
Yes, yes, joined already.
Yeah, thank you, sir.
Yeah, most of- So now say this is the standpoint of the tool. So if I mention 2, so that means this tool will come till this line. If I say on, then this tool will come, the center line will match with this. And if I say past, that means this tool will come over here. So let's understand this statement first. So go to L1 to plane 2. Now this is a plane 2. This whole thing is a plane 2. And tangent to C1. That is tangent to C1 means this is a circle. That means from here it has come till here and then it will go to the tangent point. Let's understand B. B again it is go past L1. That means from here it will come here. This is a position and then again plane 2 and tangent to C1. So it will come here. That means you imagine now what will happen in A and what will happen in B. So A will be nothing but external machining. That is the cutter is moving like this. Kaisa. Assume that this is a boundary. It's a closed boundary like this. Kaisa. Okay. So in A, external machining is happening, whereas in B, internal machining, that is cavity. Cavity is happening. If the profile is same, boundary is same, only these two and past, they are making the difference. You see, a small mistake can convert from external machining to internal machining. If it is 2, this becomes external machining, so you'll get a punch. If it is fast, this becomes a internal machining, that is you will get a cavity. There are some more motion commands. What we are discussing is the motion commands. If you want, you can write it down. There are some more motion commands, that is go LFT. So this is a syntax. You must write like this. Go LFT means it is left. Go LFT. That is move left along the drive surface. Go RGT. That is move right along the drive surface. So go left means like this. Or left like this. Go right like this. Here. Move up, that is go up. Go up means is going from here to here. That is what is your go up. Then go down means from here to here, or if the cutter is going to cut from here to here, that is called the go down. Then move forward or go forward. So this is generally used from a tangent position. That is whenever you have a straight line and an arc. Whenever you have a straight line like this and an arc, so in this case you use go forward. That is if you are moving from here to here, and other way it becomes go back or go backward. But the syntax is POBACK, that is move backward from a tangent position. Again, if you want, you can draw this diagram quickly. Now where are the points? A, B, C, D, E. This is A, this is B, this is C, this is D, and this is E. This is the isometric view and this is the top view. So you have drive surface, you have check surface, and you have part surface. And you remember this is what is your part surface, this is your drive surface, and this is your check surface. So from start, that means you have some start point, go to L1. Now where is your start point? Here. It is written clearly. This is the start with a hatching. So go to L1. Plane 1. Assume that this is a plane, or plane 1 can be this, or plane 1 can be bottom. So in this case, plane 1 is defined down, because what we are going to do, we are going to do external milling here, external machining. So it's better to define the plane 1 down, that is at this surface. So then this external surface can be milled. In this particular machining plan, we are going to machine the outside boundary. So from the start point, go to L1. So that means the cutter will touch this line.
Hello, sir.
But where now? On this line, where? Whether here, 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 where? That
Hello,
position
sir.
has to be defined. Yes.
Sir, please let Rutika in.
Do I join? Rutika.
Yes, sir. She's in.
Okay. So now, yeah. So from here now is L1. Now on this L1, where exactly that position? Whether here, 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 or here. So how that will be defined? So you have to say on L3. So on L3, this is the line L3. L3. So on means the center line of the cutter will match with this. That means at the end of this statement, at the end of this statement, the tool is exactly on this line and it has touched this L1. Now next is go right, go right oblique L1. That means this is the L1, uska right. That means obviously it has to go in this direction. It cannot be in this direction. So go right, that is on this side of L1 until where? That is till here, till here, till here, or till here. Where? So till it finds tangent point of the circle C1. So that is this point. So that means at the end of the statement 2, at the end of the statement 2, it is here. Then as I said, forward and backwards command, they are used whenever the machining is done across the profile or across the arc. So obviously this is very straightforward. That is simple. Go forward. You are going forward, isn't it? You are going in this direction. We say go forward along C1 and tangent to L2. Tangent to L2. So go forward along C1 and tangent to L2. So that means at the end of this statement 3, this cutter will move along this line and it will come till this point. Now either you can move go forward. Go forward is applicable for the arc as well as along the straight line. But the go right and go left, they are applicable for the lines only. Now here either you can use go forward or you can use go right also. Now here it is go forward that is used along L2 or go right along L2 and past L3. That means this is the line L3 जिसको कि pass कर. So the tool will come here past L3. Alright. And then obviously this is left of L3. Why they are used forward here? Because of the difficulty in understanding whether right and left. Sometimes here also they use forward. If it is vertical line, then it is clear that this is left and this is right. That is, if the cutter is moving like this, and this becomes left and this becomes right. If you write left, then it will be external machining. If you write right, RIGHT, then that becomes a internal machining. So go left of L3 and past L1. That means this line L1 line will pass. So at the end of this line, it will be on the left hand side of L3 and it will pass L1. And then the next command is go to start. That is, it will come to its initial position. It is start. Sorry. So this is what the external machining is. So we discuss geometry commands, discuss motion command. So in geometry, we discuss point, line, circle, plane. In geometry, the important was go to, then delta, then from, to, forward, then to, on, past, up and down. These are your motion statements. Now let's discuss post-processor commands. So here, this machine, see, remember, this is not a spelling mistake. You need to write like this, machine, M-A-C-H-I-N, machine. There is no E, there is not a spelling mistake, there is no E. It is like this only, M-A-C-H-I-N, machine. Drill, it's a drilling machine. And maybe drilling machine number 3. So this is like a comment. That is, you have some 10 drilling machines, so out of which this particular program you want to run it on drilling machine number 3. Then Coolant, again, there is no spelling mistake. E is silent. You're not going to write E. So COOLNT. That is your coolant. Again, in coolant, you can have options of mist coolant, flood coolant, and off coolant. COOLNT mist, COOLNT flood, COOLNT off. That means mist coolant, you know, it is nothing but it's a kind of a spray like a perfume. So here, mixture of air and oil is used as a mist. Flood coolant is whatever you see, or whatever you are seeing during your first year of workshop practicals. That is a flood coolant. It is soluble oil plus water. That white आपने जो देखा है, that is what is called as the flood coolant. Mist coolant is nothing but air plus oil. So mist coolant is used generally for the non-ferrous material. Flood coolant is used for your steel, that is MS, SS, etc., etc. And you can switch off your coolant pump motor by this command, that is COOLNT off. Some more commands, post processor commands. Again, there is no spelling mistake. E is silent. Fed rate. Fed rate is nothing but feed rate. FEEDRATE. Both the E's are silent. Feed rate is 4.5. APT program allows you to specify inch or millimeter in the beginning. In the beginning, you can specify inch and millimeter. So if we are specified, we already specified it as an inch because our dimensions are in inches, 1 inch, 2 inch, 3 inch. So now this becomes your feed rate 4.5 means feed rate is 4.5 inches per minute. Then spindle 850, that is nothing but rotational speed, that is 850 revolutions per minute RPM. Spindle is rotating at, again there is no spelling mistake here. If you write E here thinking that there is a spelling mistake, then this is wrong. You must write like this only, spindle, that is SPINDL without E. If you write here, that's wrong. You lose mark. Then turret. Turret is nothing but is a kind of a housing which accommodates the number of tools. So turret can be square turret which can accommodate 4 tools, or it can be hexagonal turret which accommodates 6 tools, or it can be octagonal turret which accommodates 8 tools, and so on. So now this is turret 12 station turret in which we have called for 11th tool, tool number 11. So how it can be called? It can be called by turret 11. Then tolerance setting. If you remember in CNC, while learning CNC program, I had taught you tolerance setting. The diagram is available in the next slide. So there are two possibilities here in tolerance setting. One is intolerance and another is out tolerance. Intolerance. So whatever we want, we have to write here. So intolerance is now here it is 0.0015 inch. 0.0015 inch. This is 15 thou means 15 divided by 1000. Out tolerance. This is 0.001 inch. It means it is 1 by 1000 of an inch. This is called as the 1 thou. In language, earlier language, it is called the 1 thou. Like we call 1 micron. This is called the 1 thou. 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 That is 1 by 1000. And this is your 15 thou. Means 15 upon 1000. So generally out tolerance is used for external machining and intolerance is used for internal machining. So what is intolerance and what is out tolerance? It gives you this distance. See, basically what happens whenever you have, you know, other than vertical or horizontal line, like say this is vertical line, that means only one axis is moving like this. All right. If this is a horizontal line, one axis is moving like this. Now, when there is a inclined line, so both the axes are moving, both the motors are moving. Or whenever there is an arc, or whenever there is a three-dimensional machining, all the three axes are moving. If is you can notice it on the control, you will see that X, Y, Z, X, Y, Z, they are all moving. X, Y, Z, they are all moving. But actually, the movement it is series of straight lines. It is series of straight line. It doesn't, you know, ऐसा नहीं, it doesn't move along the arc. This arc is composed of series of straight lines, छोटा छोटा straight lines. Like consider surface of the earth. Earth is a spherical, but we cannot, we don't, feel it that it's a spherical. So certain surface of the earth can be considered as straight. So like that, it is any round surface is made up of series of straight lines. So lower this value means the surface is good. It is closer to the arc. It is closer to the arc geometry, geometrically or geometry wise. It is very close to the arc. So if this value is low, that means the geometry of this surface is very good. If this value is high, that means uh, it is very rough surface. So in short, intolerance and out tolerance is nothing but the deviation from the desired path. So this is what my desired path is, and if you zoom it, the actual path will be like this. ऐसा रहेगा actual path. Actual path will be like this. And the lesser these values, better is this profile. And this can be specified here by command called as the intol and outtol. Again, it allows you to write part number or program number for easy identification. You can have your own coding system for writing the part number or for writing the program number. Like sometimes we write say AB means AB stands for the bits of that particular class. Or CL print. CL print is nothing but a cutter location printer file. Means this gives the location of the cutter XYZ XYZ XYZ. Then here cutter oblique 0.6 means this is the diameter of the tool. 0.6 inch means almost you can say around 14 mm, that is 25.4 into zero point 0.6. 25 6 half inch is nothing but 12.7, and then 6 25 6, so around 15 mm it will be this. So moment you write this cutter 0.6, it understand that the cutter diameter is 0.6 inch, that is around 15 mm, and then accordingly the cutter or the tool will be offset. Accordingly the cutter or the tool will be offset, and that is what is shown in this diagram. This is exactly the same what we learn tool offset commands, that is Z41, Z42 and G40. Again here you can pull the machine, that is you can write this as 0.6. So look at this slide, you can write this as 0.6, that means the tool will be offset by 0.6, tool will be offset by 0.6. But in actual, suppose if my cutter diameter is 1 inch and if I write it as 0.6, uh, machine doesn't have any sensors, it will not detect, it's not going to measure, but it will take from the value which has been mentioned here. So value which is mentioned is zero point 0.6. So the program path will be offset by 0.6. But since my cutter is 1 inch, it's actually going to dig the workpiece surface. So if I am using 1 inch cutter and if I am giving offset at 0.6, it has cut 0.2 inside. How? 1 minus zero point 0.6, that is 0.4, divided by 2, that is 0.2, zero point 2 on the either side. So the external surface you will get will be shorter. How much short you will get? You will get short by zero point 0.2 over here and zero point 0.2 here. That means in totality, if you are machining or if you are desired to machining 2 inch by 2 inch rectangular piece, and if you are playing with the offset, that is you have used a cutter diameter of zero point 0.6, but actually you have used 1 inch cutter, so you are going to get, instead of 2 inch by 2 inch, you are going to get zero point 0.4 inch shorter. That means you will get 1.6 inch by 1.6 inch surface. Similarly, you can give less also, like that is in actual it is zero point 0.6, but you can put half inch cutter, that is 0.5. So if you are using 0.5, that means it is going to leave extra material. So you will get a oversized dimensions. So this is how you can play with the offsets. So this I was talking about offset. This is what is your specified surface or the program part. Hmm. This is the center line of the cutter, actual, and then this is your offset is. Hello. Oh, uh-huh. I already informed them sir, regarding your leave. Arun underscore Rane. I already informed the industry company. Is there any problem? Hello. Hello. You have unit test, no? Yeah, you asked me. Yes. Yes, Felix. Yeah. Hello. Hello. Yeah, I already mailed HR. About the unit test. Yeah. That is HR at the rate jamesons.com. Hmm. Nah. Samruddhi Rane. No, no, today just I think 1 hour before. Yeah. Arun underscore Rane at the rate fragnel.edu.in. Why is there any problem? Just 1 hour before, ask Samruddhi Rane. No, I addressed to her. hn@gmail.com. Hello. Okay. So this is how you can play with the offset. Like say your actual tool is this, and you are giving offset this, so you will get a oversize. And if your actual tool is this, and if you are giving offset this, then you will get oversize. So you can get oversized workpiece, you can get undersized workpiece also, depending upon the offset. And if you give the correct offset as per the correct tool diameter, then you will get the correct dimensions. But sometimes what happens, you need to do roughing, then semi-finishing and finishing. And so instead of writing three programs and instead of using three different tools, the people they use the shortcut, that is they use just one tool only and one program, and they just manage with the offset. So this was the beauty of your offset. So motion statements are nothing but this from, go to, and go DLTA. Go DLTA means it will go in feed. If it is only go to, that means it will move in rapid. This is what you have to remember. So you are expecting go DLTA movement, and suppose if you use go to, then some accident will happen because the tool will move in rapid mode. Now we will see one small example for the APT. Like now you have this rectangular piece in which you need to do these two holes, that is P1 and P2. The thickness is 0.5. This is what the start point is. This is the top view and this is the front view. So now you can look here, or what I will do, I'll go to the previous slide and look at this now, this slide. So you have drawing, look at this now. P0, it is nothing but a point. I hope this is visible. P0 is nothing but a point which is defined by 0, 3.1. So 0, that's in x direction, that is this we are talking about. Then y, that is 3.0, and z, that is 0.1 up. Then P1 is a point, that is this at a distance of 1 inch and 0 point. So you define your 0 point anywhere you want and just give these points P0, P1 and point. Now from P0, now this is what is your drill. From P0, go to P1. So it will come to P1 rapidly. Say it will come to P1 rapidly. Then go DLTA. Moment it reaches DLTA, that means the motion is going to happen in feed. So it will go. Now remember, go DLTA means it has to be incremental. The dimension should be incremental. So there is no movement in x. So that's why it is 0. No movement in y. So it is 0. And then minus 0.7. So that is z minus 0.7. So this is zero point 0.5. 0.1 up approach and 0.1 down overshoot. That is 0.7. Then go TLT. Now again it is to move up. यहाँ से नीचे गया 0.7 down. So it will move up by 0.7. So 0, 0 and 0.7. And then say go to P2. That is this point. Then again go DLTA, that is 0, 0 and minus 0.7. And again it's going to move up. Go DLTA 0, 0, 0.7, and then go to P0. So that was this slide. So from P0, that is this point, go to P1, that is come here, and just 0.1 above this, and move in feed. Now here go DLTA. Here you can say go to. That is, once the drilling is done, there is no need to lift the drill in feet. You can move the drill rapidly up. So this go DLTA can be changed to go to. This can be changed to go to. Go DLTA can be changed to go to. This again can be changed to go to. So that is going to save your machining time. So if you have any doubt, you please ask. And then this will continue next time. Thank you and sorry that morning because of the off failure I could not take the class. So remember now we have come till here and then probably the next class we should be able to finish this APT program. Then I'll show some videos. Then we'll practice CNC lathe and CNC milling machine programs. If you have doubt, you please ask. Thank you very much.